All right, so hopefully you practiced your U sub, kind of the fast way, or whether you did it with the U's, the true U sub way. So I want you to practice doing, let's see if you can do this problem that's in your notes for T79. Let's see if you can do it totally without looking at anything. So I'll give you a second, stop the video, try it. And again, if it's okay with you, I probably will do it kind of the fast way. I like that way. And remember how you're like, well, how do you know if you can do it the fast way or not? In a sense, I kind of do a combination. So if my U is that inner function, so if I see a power, what's on the inside, what I'm raising to that power is a very good choice for U. My derivative of U, du, would be 4 dx. So if what's next to dx I can fix with a constant, that's meaning I can do it the fast way. If there's a variable difference, then I'm going to have to do it the true U sub way. But so I need a 4. So I like to say, well, I wish I had a 4 here. So if I put a 4 in, I have to really multiply by 1. So I'm going to put the 1/4 on the outside. Now I have the green light. This is my inner derivative. So I can have the derivative of the inner function. So I now can integrate the outer function. Well, the outer function is the power. So I increase the power by 1 and divide by that new power. I can't forget the 1/4 that was already on the outside. Notice what is in that parentheses is the same thing that's in the parentheses to begin with. I have the plus c, and of course my answer is 1/24, 4x minus 1 to the 6th plus c. So we're just doing that same thought, but we have trig in there. And trig makes it a little more complicated, and I hope that you have your trig derivatives and integrals memorized, because man, if you don't have those memorized, it's very hard to see the problem. So again, let me kind of do this problem, and I'll do it I'll do this first one 2 different ways. So I'll do it the first way, kind of the fast way I did the last problem, and if you see this, then I will do it with the U sub way. So I have the integral of sine of 6x. Now hopefully you see that as a composition. Okay, what's your inner function and what's your outer function? So again, I know I'm doing this kind of in a weird way. If I were doing the U sub way, my U, why did we pick U to be 4x minus 1? Well, that was the inner function. So if you think of sine of 6x, what is the inner function? The inner function is 6x and the outer function is the sine. So du would be 6 dx. So one person that would realize that is go, wait, the inner function is 6x. I would need a derivative of 6. So I would pull a 1/6. This is my inner derivative. So I have the green light to integrate the outer function. Well, the outer function is the sine of something. Well, what is the integral of the sine of something? The integral is negative cosine. So I would have negative cosine. The argument never changes. I have this 1/6 plus c, and that question is done. Now, if you say, I don't like that way, I like to write it out, well, let's see the U substitution way. Again, you've figured out the U and the du. So what do I have in my rewrite? This is the sine of U. Now, again, when I solve this equation for dx, I have du over 6, or 1/6 du. Now remember, if I replace that with 1/6 du, this 1/6 I didn't put in the problem myself just because I felt like it. It was in the problem. So I'm just going to move him to the outside. Instead of putting him there, I'm going to put him out there. So what I'm really integrating is the sine of u? Well, the integral of the sine of u is negative cosine of u. You have times the 1/6 plus c. And of course, your last step is to kind of combine those numbers and replace u with 6x plus c, and you have it. So again, as we go through, you can kind of choose the way that you want to do it. And I hope that you can, find the way that you like best, and I'm good with that. So again, I'll probably do my problems as a combination of the two, so you can, depending on which way you pick, you can get there. So as I look at example 2, yes, if I see trig, especially if I recognize it as being the derivative of something, I'm like, wait a minute. The integral of secant tangent, is secant tangent the derivative of somebody? Yeah. So one common thing with trig is to let the u be the argument of the trig function. Okay, I'm not saying it's always the case, and that's what makes trig hard, is that is sometimes true, but not always. But in this one, yeah, a good thing for u is 5 minus 2x. So du is going to be negative 2 dx. So if I were doing this problem, again, I would have secant of 5 minus 2x and tangent of 5 minus 2x dx. What do I need in front of dx? It's just a constant. So it's a matter of putting in that negative 2 and pulling out a negative 1/2 so that I am multiplying by 1. I have my poofy cloud. I have the green light of the inner function, which means I can integrate the outer function. Well, the outer function is secant tangent. Secant tangent is the derivative of whom? Or in other words, the integral of secant tangent is who? Well, the integral, I don't know, I'm writing that. The integral of secant tangent is just secant. So I would have the secant of something. The negative 1/2 is outside. And of course, what's in this parentheses is the same that's in the parentheses above. Okay? Remember that with trig, the arguments never change. A lot of times, I'm not saying you couldn't use trig identities on some and get to a simplified answer. Yes, but when you do the integration, the arguments of the trig functions will never change. All right, let's keep on trucking. Example 3. Okay, well, here's where it gets a little stinky, because you're like, oh gosh, I see lots of things. Should I let my u, yesterday you said, I'm going to just rewrite this. You said, well, if you see a power, then a lot of times you let your u be what's inside that power. Well, the problem with that, because that squared is squaring all that, I hope that you kind of recognize, wait a minute, there's no way I could let that be my u, because I would have to have the inner derivative, which has trig in it, which I don't have. I would have to have secant tangent, and I don't have that. So there's no way that that's going to be my u. Well, let's do this one kind of like we did the last ones. I also said that, hey, if you see a trig functions, one common good choice for u is the argument. So I'll let u be 3x squared. So if you do du, that derivative is 6x dx. And that's when you go, okay, sweetness. This x right here, although they write it in the front, I'm going to be smarter and write it like this. I have secant squared of 3x squared, and I'm going to put the x dx together so that, look, can I still do it the fast way? Yes, because I have x dx. My variables match up, so I can do the poofy cloud. What do I need next to that x dx? I need a 6. Well, if I need a 6, I have a 1/6 on the outside. I have the green light of the inner function. Now I'm integrating the outer function. What is the outer function? Secant squared of something. Who has a derivative of secant squared? Well, tangent. So the integral of secant squared is the tangent of what? Well, arguments don't change. And I have the 1/6 plus c, and that's my answer. Okay. So hopefully, I know y'all, this takes practice. It takes, again, like I said, for you to be able to see the problem, it takes you working problems. So I promise you're going to get it if you work at it. Let's look at number 4. All right. Ooh, again, lots of different stuff there. So first of all, a quotient I'm going to write this way. And again, if you start recognizing your weight, the derivative of cosine is sine. I have 4 of those. So I might try to think of this as the cosine of 2x to the what power? -4th. And then you know what? I need to write this down here so I have space. Cosine of 2x to the -4th, and then I have sine of 2x dx. I'll use this for my u space. So if I just let my u be the argument, I've got to integrate cosine sine. Like, I don't know, that's not the derivative of somebody. So in this one, it's smarter, like, okay, I do have something to a power. So I'm going to think of what we did yesterday. I'm going to put my inner function, what I'm raising to the power, as my u. Now, friends, we got to think a chain rule. What would the derivative of cosine of 2x be? Be careful, because derivatives, integrals, we have to think both ways. The derivative of cosine of 2x is negative sine of 2x times 2. And of course, I'm going to put the dx here. Look at the variables. Look at the variables you have here, and oh my stars, look at the variables you have there. They match up. The only thing I'm really missing is a -2. So can you fix that? Yep. Put the -2 in, a -1/2. I've got this. Where does all this sine of 2x go? It poofs away. It's the green light for the inner derivative. Okay? And so what am I really integrating? I'm integrating the outside function. The outside function is a power of -4. So how do I integrate something to the -4th? I would have increased the power by 1. That's -3. I divide by the new power. That's -1/3. Of course, the -1/2 is still out there. This stays because I don't change that, plus c. And then I can kind of clean it up. So I have 1 over, again, they don't like negative exponents, so most likely they would change this and they would say, oh, I could write it like this. Or they could get excited and go, ooh, let's make them do some trig identities. Having cosine in the denominator is like having secant in the numerator. So I could write it like that. So you just have to, I mean, both are correct. You have to look at your multiple choice to see it. So look at number 5. And figure out which one you think you should let be your u. Okay, ask yourself, who do I have the derivative? Whose derivative do I have? Because that's what you're going to need. So you're like, oh, do I let my u be, it's probably not going to be 4x because there's just a lot more to that. And secant squared tangent cubed is not the derivative of somebody. But so should I let my u be the secant because that's raised to a power, or should I let it be the tangent? Well, think of the derivatives of those two things, okay? If you think of the derivatives, what's the derivative of secant? Secant tangent. Well, the problem is you have 3 tangents, so you have extra ones. But if you let your u be tangent, what's the derivative of tangent? The derivative of tangent is secant squared. And you're like, oh, I'm liking that. So let's write it this way. Let's write it as tangent of 4x cubed and then secant squared of 4x dx. So if I let my u be tangent of 4x, because that would be the inner function of a power. So what do I have? What do I need by dx is I need the derivative of tangent of 4x. What's the derivative of tangent of 4x? 4 secant squared of 4x dx. And lo and behold, boop, 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 is all of that. What's the only thing I'm missing? A 4 and a 1/4. I poofy cloud that guy out of there. My green light is given. I have it. So I can integrate the outer function, which is a power, increase the power by 1, divide by the new power. This 1/4 I can't forget about. He stays in there. And my final answer is 1/16 tangent to the 4th of 4x plus c. Okay. Very good, very good. Now you try number 6. I'll tell you it's a little tricky, but try it. See what you think. So stop the video and give it a go. All right. So y'all listen. When you're new at this, you don't have to pick the right u at first. I want to kind of do this one in a weird way, or in a way that I think might happen to you guys as you're working. So let's say you went, oh, well, pretty much in most of these, I will pick, let's think of u as, I don't know, if I have to do cotangent of 8x. Well, what's the derivative of cotangent? What's the derivative of cotangent? That's negative, which the negative doesn't bother me because that's a constant, cosecant squared of 8x, and of course I would actually have negative 8. Well, I would only need 2 and I have 5. So that's kind of a problem. So you're like, nope, let's try something else. Let's try, let my u, what are your other options? Well, if you let it be 8x, du is only 8 dx. Well, the only way that would work is cosecant to the 5th times cotangent a derivative of somebody? Well, gosh, no. So that one's not going to work. So you're like, nope, let's try something else. What's the one I haven't done is cosecant of 8x. So if I did cosecant, then my du would be, you know what, I'm just going to, these edges of these, let's do it down here so I have space. Cosecant of 8x. What would du be? It would be negative cosecant cotangent times 8. Now, let's be smart. Come on, let's see if you can think of it. This times dx, I need to put a dx on that. What do I need next to dx? I need all this. Well, what do I have? Well, I have that, but I also need cosecant. So what I'm saying is, if I have cosecant of 8x to the 5th, and I have cotangent of 8x dx, how could I get this? Now the negative 8, okay, that's a matter of a constant. But remember variables, I can't add in variables. So do you see it? I know this is weird, but you have the cotangent, you need a cosecant of 8x. Well, gee, golly whiz, you have 5 of them. So you go, wait, let me just write this in a better way. Instead of having 5 of them, let me change that to 4 of them. And if I have 4, then I could put one of them right here. cosecant of 8x. Isn't that cosecant of 8x to the fifth? I haven't changed the problem. So now my variables, now I have all of this. What's the only thing I need? I need a negative 8, and I would have a negative 1/8 on the outside. All of this is my poofy cloud. I have the inner derivative, so now I can integrate the outer function, which is a power of 4. So I would increase the power by 1, divide by a new power. I have the 1/8 out there. What stays in here is the same. And so my final answer is negative 1/40th cosecant of 8x. I could write that a little bit more mathy, but I would give you credit if you wrote it the other way. But if it was typed on a multiple choice, they'd probably write it like that, plus c. Isn't that cool? So you just got to look to get that inner derivative. Last one. And of course, the last one is a stinker because it's honestly, it's the hardest thing to see, I think, because if I had a power of 4 on that sign, you'd go, oh yeah, I see it. My u is going to be sine and my derivative is cosine. The hardest thing to see is the power of 1. So I want you to look at this problem like that. Now, if I wrote it like that, I guarantee it you know how to do it. So it's just that power of 1, just watch out for that because it's very, very difficult to see. And I know you're going to hate me on this one because here's what I want. I want one side of the room, and I know you're on the video, but so you're stuck with doing it 3 times. I want one group to look at it like this, and I want the other group to look at it like this. And I want one group to let your u, on this side, let your u be sine of x, and on this side, I want your u to be cosine of x. Okay? So if you're watching this video, you're just stuck with doing it both ways. Or pick one and then just go the video. So if you're picking it to be sine of x, then your du is going to be negative, not negative. The derivative of sine is cosine. So you have cosine dx. But remember, what are you integrating? And this is where a lot of people miss. Okay, you have the sine of x, cosine of x dx. You have the inner derivative. So you're integrating the outer function. What is the outer function? A lot of people go, oh, I'm integrating sine. No, you're not. The outer function is the power of 1. So you're going to increase the power by 1, divide by the new power, and you would get this. Okay, or in other words, 1/2 sine squared of x plus c. And that is a correct answer. Now this side of the room, you said, well, the derivative of cosine is negative sine x dx, which that's not a problem because I have this variable. The only thing I'm missing is a negative, so I can add in a negative, and that's legal. Once again, I have the inner derivative, but again, what is the outer function is that power of 1. So I'd increase, divide by the new power, and I would get an answer of this, negative 1/2 cosine squared of x plus c. So you're like, well, gosh, I mean, which one's the right answer? Y'all, they're both right. I mean, they're totally both right. You know, with trig, you remember those trig identities. So technically speaking, just to explain why they're both right, is I could turn sine squared, remember the identity? Sine squared is 1 minus cosine squared. So I could do that. So I would have 1/2 minus 1/2 cosine squared x plus c. Well, this c If I add 1/2, isn't that also just some constant? So those are the same. I'm not saying those C's would be the same, but that's why you can get two different answers. And you're going to love this. Love, hate. I could also think of, remember the identity sine of 2x is equal to 2 sine x cosine x? Remember that identity? So if I solve for sine of cosine of x, so in other words, if I divide by 1/2, would you agree that those would be the same thing? Those two things? So one person would go, you know what? My original question is sine times cosine. I'm just going to change that to the integral of having one trig function rather than two. So I could do that integral. Well, that integral, I'd probably move the 1/2 to the outside because I like that. Well, if I have the sine of, if this is my u, then du would be 2 dx. I would need a 2. I would need another 1/2. What is the integral of sine? The integral of sine is negative cosine of 2x, and I would have a 1/4 on the outside plus c, and that would be a correct answer. So I need you to understand with the trig, you know, I don't put every right answer, and that is a very rare case. I'm not saying every single question has more than one answer, but on some of them, depending on how it's written, there's more than one way that you could do a U sub and get it correct. So you kind of have to think whether it's going to be the same thing or not. And I know that's kind of difficult. So just know that as you do the homework and comparing to friends or whatever. All right, y'all have a great one. Peace out.